start talking. Grab your coat and let's start walking. Come on, come on. 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 Come on, come on.
A riding leisure horse fit is generally a balanced symmetrical shoe fitted to the widest point of the frog and having sufficient enough width from the quarters to accommodate all aspects of the natural physiology of the foot. Static foot balance principles are designed to minimize the effects of impact shock and force loading through the hoof capsule during the various phases of the stride. Those forces are calculated at a theoretical point within the hoof capsule whilst the animal is stationary and at mid-stance of the stride. At mid-stance, the animal's weight, or force, is resisted by opposing forces of friction against the ground reaction force, and in combination with the pull of the common digital extensor tendon and the deep flexor tendon. The mass of the horse's weight is transferred to the hoof wall via tensile force vectors through the laminal interface. The theoretical point of force is said to be that point in the hoof capsule where all of these opposing forces neutralize each other and the foot is in a state of equilibrium. Movement within the hoof capsule is determined by turning forces, otherwise known as moment arms. These are normally of equal length and perpendicular to the line of any given force, acting much like a child's seesaw, with weight and force counterbalancing each other around a central fulcrum point. The linear ground reaction force, acting at 90 degrees to the moment arm, creates a clockwise moment. This clockwise moment is counterbalanced by the linear force of the deep digital flexor tendon. The length of a shoe, or the amount of heel support given, is an example of how the relationship between force and moment arms can affect everyday farriery. Up to 60% of the shock impact force associated with heel first landing is normally dissipated through the soft structures of the foot within milliseconds of the landing phase of the stride. Horn has elastic qualities which allow it to return to its normal form after the release of stress. The higher the magnitude of stress, the longer the cycle of strain, and the more likely that the horn is to rupture. The longer the heel of the shoe, the earlier it strikes the ground, the greater the distance between the point of force and the moment arm. The initial impact shock counteracts the moment arm, pitching the foot forward and increasing the velocity at which the remainder of the foot contacts the ground. The resultant linear force of ground reaction results in a greater rotation of the moment arm from the center of the distal interphalangeal joint, resulting in a crushing of the structures between the two opposing forces of descending weight and ascending impact shock. On a soft surface, the magnitude of stress at the heel is accentuated by the linear forces of the common digital extender tendon, which flip the toe upwards in a clockwise direction, as the extended heel slips further into the ground than would otherwise be normal. The energy being stored in the deep digital flexor tendon from the rotating phalanges is released with greater velocity to prevent hyperextension of the distal interphalangeal joint. Clip, you can see as the heels make first contact with the ground and sink into it, the phalanges begin to rotate and the toe is flipped upwards. Note the shifting of the soil from underneath the toe. Note how this recently shod horse with too much heel length contacts the ground heel first and is pitched forward, crushing the heel in between the two opposing forces. Prior to shoeing, the animal exhibited just slight heel first contact. Immediately post-shoeing, however, this action is exaggerated by the extension of the heel of the shoe, creating a counterclockwise movement as it accelerates the hoof capsule forward to the stance phase. The stress is increased at the point of impact, thus increasing the strain on the structures within the heel area, beyond their capacity to return to their original form. An examination of the role of the frog, digital cushion, heel bulbs and lateral cartilages in the expansion mechanism of the foot will give further evidence as to why shoe length needs to be proportionate to the hoof's geometry. Following initial contact, the phalanges rotate distally. Simultaneously, the frog is brought into contact with the ground as the digital cushion expands. The stress on those structures contained in the caudal third of the foot cause the hoof wall to deform, i.e. expand. As propulsive energy is released by the deep flexor tendon, the heels return to their original form. Once attached, the shoe becomes an integral part of the hoof, in that it becomes the new bearing border. In order to minimize the stress created by the addition of the shoe whilst maximizing its efficiency in terms of load bearing, its length is calculated using anatomical reference points. The point of force being estimated approximately 3/8 of an inch back from the true point of frog, and the centre of rotation of the coffin joint approximately 1 1/4 inches further back from the point of force. In conjunction with the length of the dorsal hoof wall following correct trimming, these measurements help us visualize the location of the internal structures within the hoof capsule. The length of the dorsal hoof wall is used to calculate the optimum length of the shoe. The hoof wall length should be the same as the distance from the toe to the centre of rotation of the coffin joint. This length is also used to calculate the optimum length of shoe, with the dorsal hoof wall length being measured longitudinally along the axis of the frog to the heel bulbs. This position indicates the optimum bearing length on the normal foot. Differences in the optimum of shoe length can lead to either constant premature shoe loss or lameness through foot pathology such as corns. The necessities of either work regime or environment may necessitate compromise in the fit style. These changes should be accompanied by modifications to the shoeing cycle, either greater or lesser depending on the length of shoe employed. A good leisure fit should be capable of withstanding a shoeing cycle of between 5 and 6 weeks, without compromising the integrity of the hoof wall, whilst minimizing the restrictions on hoof function imposed by the act of shoeing in itself. Constant shoe loss or hoof capsule pathology, you will be blamed for both. There is very little tolerance. Shoeing what's right. Having trimmed a foot, identify 3/8 of an inch back from the true point of frog and the widest point on the solar surface with which you can check your measurements against the length of the hoop. Fullering or creasing flat steel displaces material to the outside of the fuller groove. In order to maintain a uniform profile of section for the finished shoe, the toe of the material should be jumped up to increase its thickness and width. The toe is then bent to a uniform radius around the centre mark. The toe bend radius is locked over the bick of the anvil so that the branches form an angle of about 90 degrees to the toe bend. The outer edge of material in the toe bend region is worked back in over the bick of the anvil, and the start positions of the fuller groove identified. As a guide, these should be adjacent to the inner border of the toe on each branch. The heel is then forged by checking off the inner edge of the material to conform to the angle of the frog and blending in the outer edge of the material. An imaginary line from the point of the finished heel along the branch of the shoe should give a good indication for the fullering. The outer edge of the branch is then tapered from foot surface to ground surface by placing it on its side on the anvil and forging at an angle of about 55 degrees in the location of the fullering. It is important to ensure that not only does the branch remain level, but that it remains parallel along its length prior to fullering. The fuller is run along the branch parallel to the inner edge, with the forged outer edge accommodating any displacement within the fullering. It is important to position the fuller so that the exit hole of your nail holes falls just slightly outside of the centre of the foot surface. At this point, the depth of the fuller groove should be between half and 2/3 the thickness of the material before the branch is bent over the bick of the anvil. The shoe should be kept level, and the inner edge, which swells during bending, should be forged down on the foot surface before the fullering is finished off, to a depth of about 3/4 of the thickness of the material. The branch is then checked for alignment, shape and symmetry prior to stamping and pritcheling of the nail holes. The heel nail is placed just forward of the widest part of the shoe, and the nail holes pritchelled through at the appropriate pitch. Slugs are removed, the shoe is then levelled and seated around its inner edge to prevent sole pressure. Any distortion of the outer edge of the material caused by forging is then gently worked back in to ensure a uniform width of material along the branch. The process is then repeated to form the inside branch. A common mistake in forging the branches is to not fully support that material which is already bent against the bick of the anvil. Note that the toe of this shoe is totally unsupported, and watch what happens as the branch is bent. The unsupported material at the toe follows the branch as it is bent, opening up the radius of the inner toe. The shoe is levelled and dimensions checked. The shoe is then clipped, in this case using a punch rather than a hammer to start the material for the clip. The punch is placed on the centre mark about a third of the width of material from the outer edge, and punched downwards and outwards to form the material for the base of the clip. The clip is then formed over the edge of the anvil, pulling material with overlapping blows from the base to the tip. The finished clip's base is as wide as the original material and its height twice its thickness. shoe is then fitted to conform to the shape of the bearing border of the hoof. There should be sufficient width of shoe around the bearing border to accommodate both the natural expansion mechanism of the foot and normal hoof growth over the shoeing cycle. Once satisfied with the fit, the shoe is finished by rasping the heels and then boxing or safing any edges around the shoe which protrude from the bearing border. Prior to attachment, the shoe is then checked for outline fit and geometric proportions. The shoe is then attached and finished in the usual way. Finished leisure horse fit should exhibit good medial-lateral balance, have sufficient enough width around the peripheral border to accommodate the natural expansion of the foot as well as hoof growth over the cycle, conform to the reference points previously described, with the bearing border of the shoe centered around the coffin joint within the foot, as well as a correct hoof pastern axis and geometric proportions.